So this is week 13 Thursday. Today we're going to focus on design and analysis of beams with 3D mold circle. We're not going to learn anything new, but we're going to integrate 4 different topics to answer a question like this. Okay, you have to integrate 4 different topics. And as I said before, this is real engineering work. Okay, if you go to industry, this is what you'll be doing. Okay, so we are given a structure.
Sir,
Yes.
you're not.
Hello.
You're not sharing your screen.
Oh, sorry. Thank you for telling me.
Yeah, no worries.
You see my screen now?
Yes, I do now.
Okay. Thank God you told me about it, man. Okay. So is this problem? So today we are going to design analysis of beam with 3D mold circle. And this is one question, but we are going to apply 4 different topics to solve a problem like this. Okay. So we have a overhanging beam, as you can see. So this overhanging beam, if I were to draw transformation, this is X, this is Y, and then we have rotation about Z, and then we have our cross-section view. Now cross-section view, this is our Y, okay, and this is our Z, and this is rotation about Y. Okay, so you see over here, it's not X, this is known as our Z. Because of the figure, it was in X, but it's actually our Z. So failure occur in 2 different scales. Okay, so let me elaborate. So when we look at this level, we are looking at the macro scale. Okay, and when we look at the cross section, is we look at the micro scale. In the micro scale, we know failure will occur at this junction. Right? At the junction of the flange and web due to what? Stress concentration. Okay, and this concentration is because of the radius over here. Okay, so in the micro scale, we know where failure will occur. At the macro scale, I'm going to put in our element. Okay, this is our element. We don't know the position of the element. Okay, we don't know the position of the element yet. Okay, for now we don't know yet. Okay, so when I say we don't know the position of where the element yet, okay, at the end of the day, what we are trying to do is we need a 3D element. Okay, we need to construct a 3D element first. Okay. So we have to formulate. Okay, we need to find out. Okay, so based on the transformation X, Y, and this is our Z, we need to determine our stress X, right? And we know that stress X is equal to mz over izz multiplied by y. Okay. Then after that, we also need to determine our shear, right? So this is our shear xy, and this is our shear yx. So we are aware that shear xy is equal to shear yx, and this will be equal to VQ over IT, right? So once we can, or not once, okay. So what will affect the stress X and the shear XY value are our moments. Okay, so the moment are the one that are going to be critical. Moment Z and our V. Okay, I do apologize. I have to change the formula because we know that this will be Vy over Izz Qz over T. Then the next one is we need to find where Vy is. Okay. Now, by looking at this formula now, these two formula now, right? By looking at this formula now, as you can see, right, we will to focus on this formula. We know that stress X will be at its maximum when moment of Z is at its maximum position multiplied by Y over Izz, right? That we know, right? And then we are also aware, hold on, sorry about this. And we are also aware that shear XY max will be equal to Vy at its maximum Qz over Izz T. Okay. So we need to, for maximum, we need to locate maximum or locate position where mz is maximum. We also need to locate position where Vy is maximum. Okay. Right. So we need to find the location, right? And later on, you will see. Okay. You will observe this. Where mz is maximum, Vy is not necessarily maximum. And when Vy is maximum, mz is not necessarily maximum. Okay. So you have to check. Okay. You have to check a few places. Okay. So after what we have found, once we have find our stress X and shear XY, then we are going to use what? And from here, right? From here, we are going to construct, right? So we're going to construct 3D mold circle, right? So from here, we are going to construct 3D mold circle. Okay, normal stress, shearing stress. Okay, so we know that this is our stress X line. This you know is our stress Y and stress Z line, right? So remember we label this X, we label this Y, and we label this Z. And we know over here this is our point Z. Okay, so assuming that this is our shear line, the element rotate clockwise, element rotate anti-clockwise, and we know that this is our point X and this is our point Y. From here, okay, we have to, okay, I'm drawing freehand, unfortunately. My circle is not really a circle now. So we are going to construct 3D mold circle, right? One circle here, one circle here, and then we have a third circle here. We are going to construct 3D mold circle. And from the 3D mold circle, we are going to find what is our stress A, and then what is our stress B. Okay, so we also need to determine what, if you look at the question, we have to determine, right, the principal stresses. Can you see that? Okay, where principal stresses of the beam. And we also have to find what is our maximum stress in the beam. Okay, maximum normal stress in the beam. Okay, and I'll highlight that what do we mean by that. Okay. Right. So if you look in this context, right, this topic over here, right, this is on bending moment. This is on shear stress or shear flow or shear force or bending moment. This is on shear stress. So two topics. This is on 3D mold circle. Three topics now. Then to locate the position, right? It is based on shear force and bending moment diagram. So the prerequisite for this course is you have to know your shear force and bending moment diagram. If you have forgotten, not to worry. I'm going to do it now, how the whole thing look like. Okay. So you can see 4 different topics, 1 question. So that is why one of the reason, okay, integration of topics is so important. Only if you can integrate the topics, then you can become a what? A true engineer. Okay, if you cannot integrate the topics, it's useless. Okay, now so the first thing we're going to do, okay, so the first thing we're going to do, we're going to determine, or we're going to determine, or we're going to use or construct shear force and bending moment diagram to locate the positions of Bmax and My max or Mz max. Okay, and such that the position of failure can be identified along the beam. Okay, that's the first thing we do first. Okay, so now pretty straightforward stuff. Okay, so what we're going to do, I'm going to copy this diagram. Right, we're going to look at this diagram. Then we are going to first find the reaction at point A and point D first. Okay. So we're going to draw our free body diagram. Okay. So based on our free body diagram,